You've been waiting for this all night, haven't you? Radiocarbon. Everybody knows about radiocarbon, and we find it in fossils. You mightn't believe it, but we do. The scientific community has recognised this for many years, and they've never looked at the implications. Radiocarbon is different from the other elements I've talked about. Why? Well, it's formed differently. Cosmic rays in the upper atmosphere produce fast-moving neutrons that collide with nitrogen-14 that produces carbon-14 in the upper atmosphere, which combines with oxygen to produce carbon dioxide. It's in the air you breathe, and you're all tonight a threat to public health and safety because you're all radioactive with radiocarbon. It was in the food that you ate tonight for dinner, and we should put out a sign out there that this actually should be a nuclear-free zone, and we wouldn't let you in because you're all radioactive with radiocarbon. Now, think about it. As your body then, you go on living, the carbon-14 that you took into your body decays away and returns to nitrogen-14. And as long as you eat more food, you're going to get more radiocarbon, aren't you, to replace that which is decaying away. But your great-great-great-grandmother, when she died, she stopped eating. So since her bones have been in the cemetery, she's got less and less radiocarbon in her bones, so it's kept on decaying back to nitrogen-14. So it's quite simple. If you want to know how long, whether the tombstone is correct in when she died, you measure how much radiocarbon is in her bones and compare it to the amount of radiocarbon in your bones. And the difference, you know how quickly radiocarbon decays, you can calculate how long ago she died. That's how the method works. It's really quite simple. But here's the interesting sidelight to this story. As I said before, the equipment that is used today is so powerful that you can actually count individual radiocarbon atoms, carbon-14 atoms. However, the detection limit is as good as 0.001% of the present level of carbon-14, which is equivalent to 95,000 years. That's right, you can only go back, theoretically, you can only go back 95,000 years with radiocarbon. You don't date fossils at millions of years with radiocarbon. The reason is that radiocarbon has a half-life of 5,730 years. And it means that any ancient organic carbon conventionally older than 95,000 years, like dinosaur bones, should contain no detectable radiocarbon. Let me put it another way. If every atom in the Earth was radiocarbon, within 1 million years it all have decayed away. There'd be none left. So that's why the scientists never used radiocarbon to date fossils at millions of years. But here's the embarrassment. Even in the secular literature, yes, it's already published in the journal Radiocarbon and one other secular journal, you actually find dates, radiocarbon measurements on fossils that are supposedly up to 500 million years old, and they all have radiocarbon in them. Why did they never tell us that in their textbooks? In fact, they're all young. They're not 500 million years old. So you see, I was mischievous a little while ago, and I decided I'd collect some samples and send them to a radiocarbon lab. But I didn't tell them how old the sample was, so I sent them a piece of fossilised wood from a 189 million year old rock in England. And guess what? It returned a radiocarbon age of only 24,000 years. I took a piece of coal from Australia that was 250 million years old supposedly. It gave an age of 33,700 years. And I went up to Northern California and collected samples of ammonite shells with fossil wood next to them. Okay? And these are supposed to be 112 to 120 million years old. And look at the radiocarbon. The wood and the shell almost match one another. I had 4 samples like this, and some of them were almost exactly the same, in two different materials. So what we did in this RATE project, we decided to take coal samples from different parts of the United States that are stored at Penn State University by the US Department of Energy. And here's the samples. 3 of the samples were from coals that are supposed to be 34 to 55 million years old. 3 of the samples were from coal beds that are supposed to be 65 to 145 million years old, and 4 of them were from coal beds that are supposed to be 299 to 318 million years old. And you can see they've come from a wide distribution around the United States. And guess what? They all had radiocarbon in them. In fact, they all had about the same amount of radiocarbon in them. They were all about the same radiocarbon age. Surprise, surprise. Where did all these coal beds form? Right, during the flood. They all formed in 1 year. All these trees lived just before the flood. Would you expect to give you the same radiocarbon age? Absolutely. Whether they were supposedly 300 million years old or 40 million years old, they gave the same radiocarbon age. Isn't it great to be a creationist, as my good friend John Morris used to say? Well, we went further. We also took diamonds that are made up of carbon to see if the diamonds would have radiocarbon in them. These are conventionally dated at 1 to 3 billion years old. And yet all these diamond samples contained measurable radiocarbon regardless of whether they were 1 to 3 billion years old. So, we found similar amounts of measurable radiocarbon in coal samples regardless of their conventional age. These represented, of course, pre-flood plants buried during the flood, all at the same time. So it wasn't surprising to find that they all gave the same radiocarbon age. Yes, it was inflated, and I'll explain why in a moment, but they all gave the same radiocarbon age. And the same with the deep earth diamonds. These diamonds come from 200 miles down inside the earth. Most people don't realise they come from 200 miles down inside the earth by explosive volcanic action in just about 2 hours. And yet they had radiocarbon in them regardless of their claimed billions of years ages. And with a diamond, this can't be contamination because diamond is the hardest substance known and it's impervious to contamination. So this has to be radiocarbon that is in situ to the diamonds when they formed at the time the earth formed. And of course, not only were the coal layers therefore formed at the same time during the flood, but these deep earth diamonds must have formed at the same time as the earth itself. And so we got a direct measurement of only thousands, not billions, for the age of the earth. Well, we can conclude that because these uncalibrated radiocarbon ages confirm the biblical time scale for a young earth in the recent flood, then the conventional ages of millions and billions of years derive from the long ages of decay of the uranium and the potassium and the rubidium, etc., must have been grossly accelerated if the radiocarbon has given us a closer estimate compared to the biblical timescale. So